Good morning, all. We are present here as a part of a webinar hosted by Mechanical Department, ACE College of Engineering. The webinar intends to give a peripheral knowledge about automotive transmission systems used in vehicles. The webinar will be presented by Richu Roy Thomas of final year Mechanical Engineering Department, who is also an auto enthusiast. As we all know, the demand for automatic transmission systems has surged in recent times owing to multiple reasons. The webinar will be going through the topics that will give you an overall view about automatic transmission systems. What are the different types of automated transmission systems? Why is there a sudden surge in automated transmission systems right now in this current automobile industry? Why? What are the criteria you have to look forward to when choosing an automated transmission system? I welcome Richu Roy Thomas to present the webinar.
Thank you, sir. Morning, everyone. Today we'll be talking about automatic transmissions, as Sarah's already told. We'll be looking at some different aspects of this technology, such as different types and what goes and makes them different, what goes into making them, what are each one of those technologies' advantages and disadvantages, and also why people are opting more and more for automatic transmissions, etc. Without further ado, let's go into the presentation. As I said, we'll be looking at automatic transmissions, and let's start the presentation. Okay, before we go into automatic transmission systems, let's first try to understand what a basic transmission system is. A transmission system is simply something that we have made in order to transmit power or torque efficiently from the engine to the wheels of a vehicle. Be it a bike or a car, doesn't matter. Everything needs a transmission system. And what happens if there is no transmission system is that the power that is made by the car or the motorcycle will be directly transmitted, and that can cause certain problems. We can notice that when we drive a car or a motorcycle, we will get power only in a certain RPM range or a rev range. If there is no transmission, we have no control over when the engine or the vehicle is reaching that rev range. For example, we can see that if we shift down a gear from, say, fourth gear, then the RPM will rise. And thus, we can control what RPM the car is going in. And without a transmission system, this is not possible. And we cannot really exploit the power whenever needed. For example, when we are overtaking, if we need the power instantly, without a transmission system, we won't be able to get that power. And that is the main reason why we use transmission systems. And also, there is a factor called torque multiplication. Um, we may not have seen a transmission system in a car or a motorcycle directly, but most of us have definitely been in contact with geared bicycles, right? And we can look at that and understand that there are some gear sets. And mostly, if we are looking at a 21 speed bicycle, we can see that there are three sprockets in the front and seven sprockets at the rear. If we shift into first gear, we can see that the smallest sprocket in the front and the largest sprocket in the rear will be selected. This means that we are using a very short ratio. That means it will be easier for us to pedal, but it will be very, very hard for us to pick up speed or pick up higher speeds. It will be very easy to move, but we won't be able to carry a lot of speed. And instead, when we start moving, we'll shift into a higher gear, and that will make it easier to carry speed. However, it will be harder to accelerate. We will need more force. And that is exactly what is happening with a automotive transmission system also. In order to get moving or just start rolling, we will use a lower gear. And as we need a higher speed or to reduce the load on the engine and pick up higher mileage, we will shift into a higher gear, making it easier for the vehicle but harder for the engine. Okay, now we'll go to the next topic. Okay, we have seen what a transmission system is. Now we are looking at what an automatic transmission system is. So, put very simply, An automatic transmission is just one that does the gear shifting for you. Um, it will have a transmission system, but we won't have direct contact with the transmission system in any manner. The car will do all of the shifting by itself. And it's not only limited to cars. Some motorcycles are also starting to use transmission systems. And also, there is one type of transmission system called CVT, which we will look into later, which is used very commonly in scooters. Everything from the kinetic Honda onwards have been automatic. And we don't see that as a big thing, but now we understand that it's an automatic transmission. The automatic transmission uses certain parameters from the car, such as the speed or the RPM, and judging by that, it will shift gears automatically, and it will shift at the most efficient or most performance-oriented points, varying by the amount of throttle that we are giving it. We will also look into that further on. Okay, the next point we have to consider is why an automatic? Why not just a manual? The main point that everyone is more inclined to is convenience. A manual is much more convenient to use around the city or in high traffic areas because we don't have to deal with the clutch and also the shifter. It is pretty hard to keep depressing and releasing the clutch in a high traffic situation, and it causes a lot of strain for us. Especially for older people, it will be much harder to keep depressing and engaging the clutch, as they might have problems with their knees or something, and can cause pain. For that purpose, an automatic transmission car can be considered, and it will make life much easier for these people. And also, without the need of a shifter, we don't have to learn the shift points, or we don't have to be very intuitive with the car. We just have to press the accelerator and the car will move forward, press the brake and the car will stop. It's that easy. And the next point is smoothness. This is a point that is more of importance to luxury car owners or people who get their cars driven by somebody else. Mainly those who sit in the back seat more than in the driver's seat. Smoothness will ensure maximum comfort because a automatic transmission car will definitely improve on the shift quality. For example, if we shift a manual transmission car, we can feel a jerk or a sudden judder inside the cabin. When we shift from one gear to other, when we press the clutch, the passengers tend to move forward, and when we put the accelerator back on, the passengers will shift their weight backwards. We can eliminate that by reducing the time between shifts, and that is exactly what an automatic transmission does. The third point is the learning curve. Those who know how to drive will definitely know that there is a kind of steep learning curve if you don't know how to ride a motorcycle or if you haven't been engaged with something with a transmission before. Because we have to learn how to balance the clutch and the accelerator. Otherwise, the clutch will be worn a lot, or something can happen in the initial stages of learning. So, eliminating all of that, just a manual transmission car cannot be driven easily, whereas an automatic transmission car can be easily learned based on any previous engagement with scooters or something like that, because only the throttle and the brake are present and there is nothing else to be learned. Maybe a steering wheel, but that's kind of simple. And the next point is not one that is of much importance to common people, but in performance oriented usage or in racing, etc., this is of much importance because the speed of shift in an automatic transmission car is much higher than one in manual transmission. Uh, as we all know, robots can do a much better job at something that is being continuously done and there is not much change compared to a human being. For example, if the thing is just a simple motion, a back and forth motion, then a robot can do it repeatedly, infinite number of times, whereas a human being will experience fatigue and then it will cause problems. And just like that, the transmission speed in an automatic transmission cannot be compared with a human or a manual shift. Okay, so we know what an automatic and why we use automatics are. Next, we will slightly move into another point, which is how we shift in an automatic transmission car. Okay, in a manual transmission, we all know the gear layout, right? We have definitely seen a manual transmission gear now. There will be numbers marked from 1 to 5 or 1 to 6, depending on how many gears the car has. And it is called an H pattern because we move in the pattern of an H. 1 to 2 will be straight, and then we will cross over to third through a shape that is shaped like an H. So we call it an H pattern. However, in an automatic transmission, the shifting mechanism is slightly different. What I have shown here is a basic manual layout, basic automatic transmission layout. We can see the letters P, R, and N. P stands for park. Park basically just engages the transmission, just like we put the car in gear when we stop, to stop the car from rolling forward when parked. R is reverse. We all know what reverse is. We just use that gear to move backwards. The next one is N, which stands for neutral. And neutral decouples the car's engine from the transmission, and the car is very free to move. And we can also rev the car out in this gear, and nothing will happen. The car won't move. And then we see D. D is the drive gear, and that is the gear that we use when driving. When put in D, the gear will shift itself, and the car is completely operatable. And then we can also see that there is a plus and minus symbol given there. That is used when the car is shifted into manual mode. The shifter can be moved towards the left, and then we can use the shifter to shift up or down by moving it backwards or forwards, depending on which car it is, and based on this symbol. The plus symbol shows upshifts, and the minus symbol shows downshifts. Okay, so that was the basic layout of a automatic transmission. However, there are also other types of shifters. For example, the one we showed in the first slide. This one is a shifter that is used in the Porsche 911, and this is a slightly different design. You can see R, N, and D on the shifter itself, and then P and M are marked on buttons that are close to the shifter. R, N, and D, as I've just said, denotes reverse, neutral, and drive, whereas P and M denote park and then manual. We can use the shifter to shift between R and ND by clicking it forwards or backwards, whereas park can be engaged by pressing the button. We don't have to touch the shifter at all to engage park. And then if we put it in manual mode by clicking the M button, then the shifter can be used to shift upwards and downwards by moving the stock forwards and backwards. There are also other designs available, such as the one used by Jaguar Land Rover, which involves a rotary dial. We can rotate the dial and choose between the different gears which are marked around the dial. Okay, so the next point is adoption rate. We can see that there are a lot more automatic cars now compared to a little bit back. In olden times, automatics were considered as a very big luxury, and it was only available in Mercedes, BMWs, etc. And smaller cars were not commonly seen with an automatic. And also the ones that were available with an automatic were very expensive, more than 2 or 3 lakhs more than the manual versions. However, nowadays there are more and more automatics on the road. We can see that in 2020, 37% of all used cars that were sold in India were automatics. However, this number was much lesser in 2016, showing almost twice the growth in 4 years. And this is mainly because automatics have become more and more cheap because the technology has been improved and the manufacturing process has been streamlined, making it much easier to manufacture automatics. Also, now what numbers we are looked at now were used car numbers, whereas also the newer cars, the sales of newer cars have been affected, and this change is being seen there too. 20% of new cars sold in India were automatics last year, and the manual, the number of amount of population using manual transmission is going down. And these are basically the numbers which are seen in India, whereas on a global scale, the ratio is much different. More than half the cars sold in other countries are automatics. And in some countries where automatics were seen from a much earlier period, such as the USA, automatics are considered, almost all cars are just deemed to be automatics, and manuals are the rarer option. For example, some cars with a manual are considered to be unicorns in the USA because they don't get to see much of them. And this is the direction that India is also headed to, as we can see the growth of the number. Okay, the next point is the beginning or the history of the automatic transmission. So in 1921, a person called Alfred Horner Munro designed an automatic transmission using a coupling that used compressed air. So compressed air was used to join the engine with the transmission, and the compressed air was the one that is transferring the power from the engine to the transmission. However, that was a flawed design, and it was much improved later on in 1930 by General Motors. General Motors is the parent company of Chevrolet, as we all know, and they improved this design by using a viscous fluid. So the compressed air was replaced by a viscous fluid because this viscous fluid can transmit much more energy compared to the compressed air. And then 18 years later, on 1948, Oldsmobile, which is a US based manufacturer, released the first automatic car that was available to the public. And the automatic transmission in that car was called the Hydramatic. They use the word Hydra because it used a fluid coupling, and fluid connects to Hydra, and that's the name. And the basic design of that transmission is the one that is still used in modern transmissions, such as the torque converter automatic, which we'll take a look at later. Okay, now we're going into the most important and most interesting part of the presentation, which are the types of automatics. There are some commonly used type of automatics, and they are divided into four types. And these main four types have been given many different names by different manufacturers. But uh, taking basically, these are the four types of automatics that are being sold to the public. And these four types are the automated manual transmission, or AMT, as we come to know it, the torque converter automatic, the continuously variable transmission, or the CVT as it is called, and the dual clutch transmission, or the DCT. These are the basic classification, but they have been given different names by other companies, as I've already said. For example, the DCT has been called DSG, or direct shift gearbox, by Volkswagen, and it has also been called PDK by Porsche. And the automated manual transmission has been named as AGS, or auto gear shift, by Maruti Suzuki, and so on and so forth. So we'll delve into the interesting part. Okay, so first of all, we will be looking at the automated manual transmission. There's a reason I've chosen this to go first, and that is because an automated manual transmission is not completely an automatic transmission. It uses a basic manual gearbox, which is shifted by a robotized actuator. And what happens is, in a manual car, when we depress the clutch, what actually happens is that a cable is moved, and the cable disengages the clutch from the engine. And what happens is, the engine and the transmission will be disconnected. That means there is no load on the transmission, and we can easily shift gears. And also, when we move the gear shifter, another set of cables have been is set in motion, and these are the cables that guide the shifter fork into choosing what gear is needed. What happens is, as we can see in this image, this blue box that is put on top of the transmission system is a robotized actuator. What it does is simply it controls the cables that normally we operate. So whenever the transmission needs to be shifted, the robotized actuator will pull the cables and depress the clutch, and also the another set of cables will be pulled by the robotized actuator itself, and the gears will be changed. Uh, the points that the points that are needed to be shifted are predetermined by the company and fed into the ECU, or the electronic control unit of the car. That is basically a computer that monitors all the motions and all the parameters of the car, and it sends a signal depending on the RPM or the speed of the car. In some systems, it might use the RPM. For example, let's say when in normal driving conditions, the car will shift at around 3,500 RPM, and when driven aggressively, it will shift at 5,000 RPM. That is depending on the throttle input. If you are giving more throttle input, then the car tends to rev out to a higher RPM. And if you are using lesser input, then the car will be aiming for efficiency, and it will shift at a lower RPM. These points have been predetermined, and the robotized actuator that we see here will shift the gears and actuate the clutch at the predetermined points. Okay, so the main advantages of the automated manual transmission system is that it's very cheap to produce, because they can use the already existing manual transmission gearbox, and then simply add a robotized actuator on top, and then program that actuator. So the production or the design cost is not that high, because a new gearbox is not being made. And this means it is more accessible to much smaller budgets. And that means that people who are looking at a small car, or people who are not ready or willing to spend lots of money on cars, can still get an automatic transmission by opting for the AMT. And this is not even a very small gap. For example, if we take a car which has both an AMT and a torque converter as options, the torque converter car could cost between 1 and 2 lakhs more than the manual transmission option, whereas the AMT might only cost around 35 to 50,000 more. It's that much of a difference, and that is why small problems of the automated manual transmissions are more often than not overlooked. There can be slight jerking in the gear shifting, because unlike the others, there is still the clutch action going on, but it is simply being robotized. So there can be jerking, but due to the huge price difference, people are more forgiving towards automated manual transmissions. And also, Maruti Suzuki is the company that can be credited with the huge popularity of AMTs because they launched it with the Celerio. And now, most cheap cars that are being sold by Maruti, cars under 5 or 6 lakhs, still have a automated manual transmission and thus an automatic transmission option. So the next type of transmission is the torque converter auto. This one we won't be going into much detail because it's a very complicated type of transmission, and we will simply look at a simpler method of explaining. And you will learn more about this later if you opt for an engineering stream. And so we will just look at what it simply is. Okay, this is the most common type of automatics, and these have been in use from a long time. So the first automatic that we talked about, which used a compressed air coupling, was also a type of torque converter. And what happens is there are two sets of vanes in the sides of the torque converter donut-shaped object, and we can see these vanes here in the impeller. Inside there are we can see that there are small shapes that are there. Those are called the vanes, and this coupling is this is an opened up torque converter, and usually it will be closed, and inside there will be a liquid or a fluid. It will be a viscous fluid which can transmit energy. And when the engine RPM rises, the side that is from the engine, the impeller side, will rotate at a speed that is proportional to the RPM. And when the speed rises, these vanes will move the fluid and will act like a pump, and the fluid will be moved on to the turbine. And the turbine is basically connected to the transmission. And with the rotation of the impeller, the turbine also rotates because the fluid is being pumped. And the shape of the vanes have been decided in such a way that maximum torque will be transmitted by this rotation. And this can be quite complicated to understand. So there is a simpler way of understanding this. If we take two table fans and put them facing each other, and we switch on only one table fan, with a little bit of time, the other table fan will also start to rotate because of the air that is produced by the first table fan. That is exactly what is happening here. The rotation of the impeller will cause the turbine also to rotate, which means that there is power transmission or torque transmission that is happening in between these two. The stator is simply there to direct the oil flow back into the impeller. Whenever we let off the throttle, the RPM will reduce and the speed of the rotation will also reduce, and the oil will come back, or oil or fluid will come back through the stator into the reservoir. This is actually used in place of the clutch, and it's not actually a complete transmission system. The transmission system includes planetary gears, and that is not a topic that we'll be going more deeply into now because it's a pretty complicated topic, and you will learn it much more if you opt for an engineering stream. So this main advantage of this torque converters is that they are very reliable, because we have seen that they have been in use from pretty much 1948 for the public. So they have been pretty much perfected by brands as they have been in use for a long time. Small problems that might occur have been cured and have been taken care of. And nowadays, it's a very reliable gearbox. They are the ones that are most likely to last around the same time as a manual, whereas the other automatic transmissions might cause more slighter problems on the long run. So the next type of transmission is the continuously variable transmission, or the CVT. It is called so because it does not have certain gear ratios, such as in a manual transmission. We can see that in a manual, there are gear ratios from ranging from 1 to 6 in most cars. And each of those are a fixed gear. There is no variability in between them. What happens here, as we have talked about in the cycles case, uh, each gears have is a set ratio or a set size of the sprockets, and that means shifting from first to seconds means a direct jump from a certain ratio to another. It is not a gradual or a continuous process. Uh, but here, in a continuously variable transmission, as we can see, the drive pulley and the driven pulley, they both consist of two cones. And if you can imagine two cones being touched at the tip, the point of touch is a very small diameter area, and thus that can act as a smaller sprocket. Whereas if we put it in full contact with each other, the sides of the cones are in full contact with each other. The diameter that is going around this contact point will be much higher, and that will act as the higher sprocket. That's exactly what happens here. There are the drive pulley and driven pulley consist of two cones which can vary in diameter at the center, and there is a belt that is transmitting the torque. So what happens is when we set off, the drive pulley will have a much smaller diameter by distancing the cones from each other, and that will provide a much shorter gear. And in the same time, the driven pulley will come closer to each other, and thus provide a bigger diameter or a larger sprocket effectively. And that means we get a lower gear ratio to start off. And as we give in more throttle input or more accelerator input, the distance between the cones will vary completely. And at maximum throttle, it will be completely different and straight opposite. The drive pulley will come closer to each other. The cones in the drive pulley will come closer to each other and thus create an effective larger sprocket. And the driven pulleys will go apart from each other and thus effectively create a smaller sprocket. And that means if we will get what is essentially the top gear in other vehicles. However, the transition between these two, unlike other transmission systems, will not be a hard shift, and it will be a continuous and smooth motion. However, the problem with this is called the rubber band effect. If we are cruising down the highway, then the transmission will be in the second scenario. That means the drive pulley will be in a will be in a larger ratio, and the driven pulley will be in a smaller ratio. And thus, what happens is the car is essentially in higher gear. If we put the foot down to overtake, if we give the car full accelerator, what happens is the transition is not sudden like in other gearboxes. It will take a little bit of time to switch between the top gear phase and the lowest gear phase. And this will cause the car to simply go up in revs. The RPM will suddenly rise. However, the acceleration will not be there. That means it's not as responsive as the other systems. This could be a problem in higher performance applications, and therefore CVTs are not commonly seen in cars that produce higher power or cars that are supposed to go faster. CVTs are most commonly used in smaller cars or cars that are supposed to be driven in highways and driven in the city and not in the highways. And that means that it is not as responsive and are usually seen in cars with lower power and that are not driver focused. So CVTs can be easier to drive, however, not as responsive to drive. The next type of transmission we are looking at is a dual clutch transmission. And while the figure might seem to be much more complicated than the others, this is actually pretty straightforward. Instead of one clutch that is working in the transmission, the dual clutch transmission, as the name suggests, uses two clutches. And we might wonder what the purpose of these two clutches are. So essentially, one clutch handles the odd numbered gears and the other clutch handles the even numbered gears. And what happens is, if we are in first gear, one clutch will be operating the first gear, and the other clutch will already be preparing the second gear for the shift. That means the shift is instant. We don't have to use the single clutch and shift from first to second. And instead, the second gear is already engaged and kept ready by the secondary clutch. And when we shift, it's an instantaneous shift. DSC or DCTs can shift under 100 milliseconds, which is unimaginable for normal human beings or average drivers. Even professional drivers can't shift that fast. And thus, DCTs are more commonly used in high performance applications. So the main importance of the DCT is that they are much more efficient in transmitting torque. We can credit that to the usage of dry clutches. Normal cars use wet clutches, which means that the clutch is immersed in oil. The oil ensures that there is lesser friction between the clutch plates and thus ensures longer life of the clutch. However, what happens in dual clutch transmissions are to increase the torque availability or the torque transmission, the clutch is not immersed in oil, and instead they are made of much higher quality material such as Kevlar or carbon. However, this can drive up the price insanely high. A Kevlar clutch can cost anywhere from twice to thrice as much as a normal clutch. And also, since there is much more friction involved, the life of the clutch is not as long as much as the other types of transmission systems. Also, since it is not immersed in oil, there is high friction, and it can also cause premature wear, and it can cause problems with the transmission that the others do not have. This has been seen in the Volkswagen Polo GT TSI edition, which uses a DCT gearbox. And many owners have complained of lesser clutch life and also mechatronic failure in this types of transmission. And these are not exactly the most reliable ones. And the brand Volkswagen themselves have shifted to a torque converter automatic in the newest or latest iteration of the Polo. So, as I said, they are more commonly used in more expensive and more performance-oriented cars, as the owners of those cars might not have a problem with the higher maintenance costs or the higher or the lesser life of this transmission, and they might be more willing to spend money for quality. And these are only seen in very few smaller cars, such as the Kia Seltos and the previous generation Volkswagen Polo. However, they are definitely facing issues here, and even the Kia Seltos has been recently facing some issues in our climate. And the Polo has already shifted to the torque converter, as I've already said. So these are not really relevant anymore. Um, and torque converters are slowly but surely replacing this as they are improving in shift times also. And also another point that can be noted is that DCTs can offer a manual shifting option using paddle shifters, whereas other transmission might also offer this. They are not as fast as the DCTs. This means in professional drivers can put the car in the exact RPM that they need in racing applications or in sudden overtakes, and it does not require complete reliance on the transmission system itself, and we can control the car's RPM. Okay, the next point that we'll be looking at is selecting the right option. So we have seen that there are different types of transmissions. However, how does one choose between these transmission options? If we choose the wrong option, then it can be a burden and it can reduce our peace of mind drastically. Because somebody who is simply driving in the city does not require a DCT, and they might only require a CVT. And a CVT, if they are opting for it, can offer much lesser maintenance and a much smoother and more pleasant driving experience if the person is not heavy on the throttle. However, if that same person opts for a DCT, it might not fit his needs and it might incur higher operational costs, etc., and might completely ruin that person's driving experience. And we can take a look at how we can select the right option. So torque converters are basically called as the all-rounders in the industry because they can give quite good fuel economy while also giving pretty fast shifts. And this is the point that has been considered when recently even BMW has shifted to a torque converter automatic in their latest sports sedan, the BMW M3, which previously used the DCT. However, the transition into the torque converter hasn't really taken much away from the driving experience, according to reviewers. And the shift times are also comparable. While, whereas it might not be as fast as a DCT, the trade-off is pretty reasonable, as we are only trading off milliseconds in the shift times for much longer life and also much better reliability. And thus, torque converters can be opted by anyone, basically anyone who requires an automatic transmission. Not and it's not dependent on what type of driving the person is doing. Okay, next, the CVTs are, as I have mentioned, much more of use in the city and not in highways or spirited driving, as they are not as responsive. And as I talked about, the rubber band effect is also there. So it might not offer the best involving driving experience. However, it can pass off as a very easy to drive transmission system, and it is opted more for simplicity than anything else. They're also much easier to maintain as a belt change in a CVT is not of much cost, and the components are also much cheaper than the other options. Okay, so the AMTs, the main selling point for the AMTs, as I've told, was the cost. So they cost much lesser than the other transmission systems, and people who are opting for smaller cars definitely see this as an advantage. Earlier, the Maruti Suzuki A-Star and all were offered as an automatic, but they used to use CVTs. And CVTs, even though they are easier to maintain, uh, they do definitely cost more than an AMT. And an AMT can even bring the price further down from the CVTs, thus offering an automatic for people who are very price conscious. Also, people who are not much focused on the driving experience. For example, people who use the AMT car as their secondary or their tertiary car for small grocery runs only, they might not be as concerned with the shift quality or something else, and they can easily go for an AMT and save a lot of cash. Okay, so DCTs. DCTs actually are a very good transmission system. Uh, However, the only problem that they are facing is the reliability, and they actually offer the best of everything. DCT cars offer better fuel economy than their manual counterparts, and they also shift incredibly fast, under 100 milliseconds, as I've already told. And this means that they're offering everything except reliability. However, in a country like ours with a tropical climate, they are not at all a very good option to go for. And the manufacturer themselves are noticing that and slightly pulling away from using DSGs or DCTs. And they are best kept aside for drivers who are more into driving, or they are more into sports driving or high performance driving, etc. So basically, people who are willing to spend more money for a better driving experience. And also, one thing that has to be noted is that they are a relatively newer technology and has not been around for as long as the torque converters or the CVTs. And we can definitely hope that in the future the DCTs will be improved upon and they can provide a longer life and a better driving experience. And one point that has to be noted is that AMTs, whereas now they are seen in smaller cars ranging from 3 to 6 lakhs also, they were commonly used in supercars in earlier times. For example, the Ferrari F40 used to use an AMT, and the even the many of the older supercars used to come with an AMT, and even the Lamborghini Aventador, it uses an AMT, and the shifts are not as smooth as the other cars. However, it is a reliable technology that can be used in high performance applications also. And so we'll go to the next point. Okay, now we have to look at the future. From the past, we are going to the future, and we are looking at the scope of automatic transmissions in electric vehicles. So what we had previously thought was that electric vehicles do not use transmissions at all, and the scope is very low. However, we have been proven wrong recently by Porsche. Porsche's EV, the Taycan, currently uses a two-speed automatic transmission. This has been designed by ZF, which is a very famous transmission manufacturer and has made transmissions for the recent BMW M3, as I've said, from that car all the way to the Pagani cars, which are hypercars. And they have designed a two-speed automatic for the Taycan, which according to Porsche, improves mileage or range in the case of electric vehicles by 5%, whereas also providing a much better top speed. Top speed has always been an issue in electric cars as they provide low down torque, but the RPM or the gear ratios aren't available. So they top out whenever the motor tops out at its maximum RPM. And this can be seen in the case of the Tata Nexon. The Nexon EV tops out at 120 kmph, whereas their diesel counterparts are capable of going more than 160 or 170 even. So electric cars have been affected by this problem a lot. And the two-speed automatic has been Porsche's answer to this. And essentially, the car always drives in the second gear. Uh, Only in instances where very high acceleration is needed, the car uses the first gear. And in all other points, the car uses the second gear. If the car is in sport or sport plus mode, then the car uses the first gear to set off, thus ensuring maximum acceleration. And even in normal mode, if you need the car to go into first gear, then you will have to put the foot down or give 100% throttle input for the car to um, recommend the first gear. In all other conditions, the second gear itself is enough, and the second gear is a much larger gear than the first one. For example, if in the case of the bicycle, as I've said earlier, the shift between a sixth to around 12th gear can be considered as the Porsche's first to second shift, and thus the second gear is much longer gear and offers much higher top speed, whereas putting much lesser load on the engine. And as I said earlier, AMTs have been seen in supercars earlier and has been trickled down into smaller cars nowadays. And just like that, we can sure hope that this technology, which is now only seen in the Porsche Taycan, which is a 3 crore plus rupee car, will eventually make its way down to smaller EVs and then into microcars even. When Maruti Suzuki, etc., launches their own electric vehicles, we can be almost sure that they will also implement this kind of technology in the coming years. So that's all we had in our agenda for this presentation. Now I will shift back to Afsal sir for talking to you.
The automatic transmission systems, mm, and how it is different from the manual transmission systems which we uh, which is generally used in this Indian automobile industries and in the automobile market scenario. But um, why? What was the reason that we chose this topic to give a little information about it to the citizens of tomorrow, or engineers of tomorrow, is because of growing interest in the same field. We are all familiar with manual transmission systems, which uh, which we see right now around us. But why is there such a growing interest in automated transmission systems? What is the need to transfer from an existing obsolete system to an universally accepted system, which is generally followed in the US, in the Middle East, and the rest parts of the world. Also, as you can see, this is a automobile related topic. You might wonder, we are a mechanical, the webinar is being hosted by mechanical engineering department, and yet we chose an automobile topic. The reason for this is the general perception among the public is that automobile industry equates to mechanical engineering, which is actually not the case. The automobile industry is just a part of mechanical engineering, just like aerospace is, just like aeronautical is, just like uh, robotics is, just like instrumentation is, just like cryogenics is. But the perception has been, in the general public, is that automobile mechanical engineering can only rotates around, or the automobile industry is confined, or the mechanical engineering department is confined to the automobile industry. I would like to, challenge that. Rather than challenging it, I would like to present you with the truth that the scope of mechanical engineering is much more than that. There are varying jobs, not belittling the automobile industry. Of course, the automobile industry has provided mechanical engineers with jobs for the last 2, 3, 4 centuries. Mm, we have been we mechanical engineers can be lucky enough to say that we have been part of changing human civilization for the good. Uh, but I would like to pass on to the knowledge that uh, it is not just confined to automobile, but it is a wide variety. It has interest in wide variety of fields. The topic we addressed right now, which was automatic transmission systems, is actually uh, a topic that needs to be addressed in depth. Every system, addressing every system in its own is a tedious task. This is the reason we just went through it peripherally. Once you opt for a mechanical engineering stream, um, you would be able to study in detail about each and every automatic transmission systems. But right now, I would like to throw some light into various scope of mechanical engineering other than the automobile industry, as I have said to you. The private sector employs mechanical engineers in various fields. We have already discussed how much jobs the automobile sector, or the scope of mechanical engineering in automobile sector. The energy sector also provides large job opportunities like petroleum industry, um, like the renewable energy industries, um, which all employ mechanical engineers. There is also a wide variety of scope in the design field, which involves design of products, design of cars, design of buildings. Um, Also, the construction industry, where mechanical engineers are involved in the field of HVAC, heating, ventilation, and air conditioning. Also, in erection of buildings, mm, in the safety, fire and safety department, uh, and plumbing sections in buildings. Mechanical engineers are also employed in IT sector. MNCs like TCS, Infosys show an interest in hiring mechanical engineers because of their know-how in mechanical related subjects and design. Also, you have wide variety of scope in the teaching field. Now, you might be thinking, how are mechanical engineers getting into teaching field or teaching or training fields? Uh, Though for a master's degree, you get to teach undergrad students, or you can also go for various add-on courses like welding, um, piping, fire and safety, so on and so forth, that teach unskilled workers to get into the field. Also, mechanical engineers are employed in management field for their knowledge in management subject. Uh, this has been seen in employers like Flipkart, where mechanical engineers have been employed as business executives and so on. The reason uh, is because mechanical engineering courses has subjects like total quality management, principles of management, which addresses management side of engineering, or in the management side of jobs. And hence, to utilize this, uh, private companies make sure they hire mechanics. Also, one of the most promising fields for mechanical engineers is the refrigeration and cooling industry, the art of cooling, or the science of cooling, to be precise, where where the the air conditioning systems, food storage, food preservation, which is a vital industry for the food security and growth of a nation. Mechanical engineers are also employed in metallurgy and material science, which involves with mining of different elements, different metals, and conversion of it into um, useful products. Various employers of mechanical engineers are, as we can see, Jaguar Land Rover and Tata. Jaguar is already owned by Tata Motors, which we have already addressed um, in in the scope of mechanical engineers in the automobile industry. There is also Ashok Leyland, which is again another company. And coming into the energy sector, we have Atnok and Reliance. Reliance owned by Mukesh Ambani, um, which is a household name. Um, there are lots of mechanical engineers have been. There are lots of opportunities for mechanical engineers in energy sector, especially in the private sector. Siemens is another company which is involved in the energy sector. Adani is involved in harbor development in Advenium. Vedanta is a mining company that hires mechanical engineers, metallurgy and material science engineers, which is actually a sub uh, branch of mechanical engineering. JCB is another earth movers. It's a company that manufactures earth movers, which again employs mechanical engineers. Lastman Tubro, Bosch, DLF. Lastman Tubro is a construction giant. Bosch deals with automotive parts. DLF is a realtor. Tata Alexei, Tata Consultancy Services. Flipkart, as I already mentioned, it's actually an e-commerce giant. But there are many mechanical engineers that have pursued management studies and went on to work in um, these e-commerce giants. Linde is a cryogenic gases manufacturing company. We all know we are facing a oxygen crisis right now in our nation. Linde is one of the companies that supply liquid oxygen uh, to us. The art of cooling, subcooling and cooling gases or liquefying gases comes under a mechanical engineering department, which is the science is called cryogenics. We also have employees in Byju's, LG, Whitehead Junior. Now, these all right now what I have addressed is the private sector that is involved in providing job opportunities to mechanical engineers. Now, coming to the government sector, we have the oil industry providing jobs, the civil aviation department, where the Airport Authority of India calls for young mechanical engineers every year. We have the DRDO, Defense Research Laboratories, the DRDO, the PWD, Public Works Department, calling for mechanical engineers or inviting mechanical engineers for competitive. We have ISRO who hires mechanical engineers every year. Um, we have various power plant corporations that is involved, like Coal India Corporation, the Power Plant Corporation of India, and power generation uh, corporations, power generation public sector companies that hire mechanical engineers. The Indian Air Force also has a direct recruitment policy for general engineers, also even for mechanical engineers, um, because a need for them to deal with aircrafts puts mechanical engineers in an advantageous position to get hired into Indian forces. The railways is the largest employer in India, and mechanical engineers, there are a large number of mechanical engineers that are employed in Indian railways as loco pilots, as assistant engineers, as senior engineers, etc. These are the various public sector companies that mm, provide job opportunities to mechanical engineers. Oil and gas, steel, Bharat Petroleum. In Kerala, we have Kerala Water Authority. We have ISRO, NALCO, Cochin Shipyard that is involved with shipbuilding. Indian Railways, NTPC, Thermal Power Corporation, called in. Okay, I think you all might have received uh, good knowledge, or good knowledge regarding automotive industries, and also I made this presentation, the last bit of presentation, to make a point that mechanical engineering is not all about automobile industry. It has wide variety of scope. Pursuing mechanical engineering would actually open you up to a large number of job opportunities, just not in the automobile, but as there is a public perception, but uh, in different fields of economy. I would like to uh, I hope that the webinar benefited you in actually rekindling your interest in automobiles and even in mechanical engineering. I would like to thank Richu Roy Thomas for the wonderful presentation. I would like to thank ACE College of Engineering and Mechanical Engineering Department uh, in helping me organize this webinar. Um, Let us all pray to Almighty in overcoming the current situation right now, the difficult situation right now we are in. Um, I would like to conclude this webinar, and once again, thank you all for attending this webinar. Mm, I expect and I hope it has immensely helped you. Um, thank you again. Uh, I would like to conclude.